A simple random sample of front seat occupants involved in car crashes is obtained. Among 2,845 occupants not wearing seatbelts, 27 were killed. Among 7,643 occupants wearing seatbelts, 14 were killed. Use a 0.05 significance level to test the claim that seatbelts are effective in reducing fatalities. Test the claim using a hypothesis test. Consider the first sample to be the sample of occupants not wearing seatbelts and the second sample to be the sample of occupants wearing seatbelts. What are the null and the alternate hypotheses? The claim is that the seatbelts are effective in reducing fatalities. That is, the fatality rate for people not wearing seatbelts, P1, is higher than fatality rate for people wearing seatbelts, P2. This can be expressed in a symbolic form as P1 is greater than P2. So it's going to be B, P1 is greater than P2 for the alternate hypotheses, because this is the expression which doesn't contain equality, and the null hypothesis is going to be P1 equals to P2, and this is the expression that always has equality. So let's go ahead and use StatCrunch. We're working with two proportion and two samples. One is wearing seatbelt and the other one is not wearing seatbelt. So proportion, two sample with summary. Let's enter the information. So sample one is the people, occupants not wearing seatbelts, and the number of successes is the number of people that are killed. So in sample one, among 2,845 occupants not wearing seatbelts, so this is the total number of observations, which is 2,400 or 2,845. 27 were killed. And sample two is people wearing seatbelts. So among 7,643, 14 were killed. So we're doing a hypothesis test. So if P1 equals P2, then the difference is 0. And if P1 is greater than P2, the difference is greater than 0. So it's going to be a right tail test. Let's choose p-value plot to see the graph. If we click compute, we're going to see the test statistic and the p-value. And on the next page, you're going to see it's a right tail test. Very small areas shaded. And that's the test statistic. And the shaded area is less than 0.001. So the test statistic rounded to 2 decimal places is going to be 5.59. And the test statistic rounded to 3 decimal places ends up being 0. So we reject the null if p-value is less than significance level. We fail to reject the null if p-value is greater than significance level. Our p-value is 0, which is less than significance level. So we're going to reject the null. So since p-value is less than significance level, and our significance level is 0.05, we're going to reject the null hypothesis. So we're rejecting the null. That means we have enough evidence to support the alternate hypothesis. So now test the claim by constructing a confidence interval. So we're working with 0.05 significance level, and the alternate hypothesis is greater. So that means it's a right tail test, one tail test. So from that, we can figure out what level to use. So here's a chart. We're working with 0.05 significance level, and we're working with a right tail test, one tail test. So we're gonna use a 90% confidence interval according to this table. So let's go ahead and go on options, edit, select confidence interval and choose 90%. So here we have the lower and upper limits for our confidence interval or confidence limits. So the lower limit rounded to 3 decimal places is 0.005. And the upper limit is going to be 0.011. So from here, we're going to make a conclusion about the confidence interval. If the confidence interval, which is the difference between P1 and P2, doesn't contain or include 0, there is evidence suggesting that P1 and P2 are not equal. So in our case, the confidence interval starts from 0.005 and ends at 0.011. So it starts from a positive number and ends at a positive number. So that means it doesn't include 0. So that means P1 minus P2 is not 0. So that means they're not equal. So if they're not equal, then this suggests that alternate hypothesis is true. So it appears that the two fatality rates are not equal because the confidence interval only has positive values. So it appears that the fatality rate is higher for those not wearing seatbelts. What did the results suggest about the effectiveness of seatbelts? So it does suggest that wearing a seatbelt is effective. So the results suggest that the use of seatbelts is associated with lower fatality rates than not using seatbelts.